Welcome to The Explainer. Today, we are pulling back the curtain on one of the most powerful, yet kind of invisible forces that shapes our digital world. We're talking about the engine that runs a massive piece of the internet, Amazon Web Services. So, have you ever stopped to really think about this? I mean, seriously, you've got millions of people logging in, streaming movies, playing games, and shopping, all at the exact same moment. How on earth does the tech behind that actually work without just completely falling apart? Well, it turns out that all these huge household names, the ones we use for entertainment, travel, gaming, even banking, they're all leaning on the very same powerful platform to make their magic happen on a global scale. And the answer is Amazon Web Services, or as pretty much everyone calls it, AWS. And trust me, it's not just some product. It was a total revolution in how we build and use technology. So what is it really? Okay, at its core, AWS is this giant cloud platform that's been around since 2006. What it does is let anyone, from a student in their dorm room to a behemoth like Netflix, rent world-class computer infrastructure. The pay-as-you-go part was the real game changer. Suddenly, you didn't need millions for your own servers, you could just rent them. This idea fueled so much of the startup boom we've seen. Probably the best way to wrap your head around it is this. Think of AWS as a utility company, but for computing, right? You don't build your own power plant just to turn on the lights at home. You just plug into the grid and pay for what you use. AWS is the exact same idea, but for things like processing power, data storage, and all the other digital tools you need to run an app. All right, so if AWS is this giant digital toolkit, what are the actual tools inside? Let's take a look at the fundamental building blocks that developers are using to create the apps we use every single day. First up, you need compute. You know, the brains of the operation. The classic service here is Amazon EC2. All it is really is a way to rent a virtual server. So instead of buying a big physical machine and sticking it in a server closet, you can spin one up in the cloud in just minutes, and you get to choose exactly how powerful it is. But then there's this totally different approach called Lambda. It's known as serverless computing. Now, that doesn't mean there aren't servers. Of course there are. It just means you don't have to think about them at all. You just upload your code and AWS automatically runs it for you only when it's triggered. You only get charged for the literal milliseconds it's running. It's pretty wild. So this really highlights a huge choice developers get to make. On one hand, you've got EC2, where you have total control over a server that's always on, ready for anything. On the other hand, you have Lambda, where you give up that fine-grained control for pure convenience. No servers to manage, your code just runs. It's that classic trade-off. Do you want more control or more efficiency? Okay, so you have the brain power, but where do you put all your stuff, your files, your images, your data? That's where Amazon S3 comes in. The easiest way to think of it is just as an infinite digital filing cabinet in the sky. It's built to store and retrieve any amount of data from anywhere on the internet. And check out this number. This represents S3's durability. It basically means it's designed with so much redundancy across so many locations that the chance of you ever losing a file you store there is, well, it's practically zero. That's a level of security that's almost impossible to replicate on your own. Of course, data isn't just about storing files. It has to be organized. And AWS has a whole bunch of specialized databases for different kinds of jobs. If you have structured data, like customer orders, you'd probably use something like RDS. For a super fast, real-time app like a mobile game, you'd want DynamoDB. And if you need to analyze just mountains of data for business insights, that's what Redshift is for. So, last piece of the puzzle. How does all of this stuff get from the cloud to your screen so fast? That's the job of services like CloudFront, which is a content delivery network. What it does is it stores copies of content, like videos and images, in data centers all around the world. So when you stream a movie on Netflix, you're not pulling it from a server in California, you're probably getting it from one that's just a few miles away from you. That's what makes everything feel so instant. But AWS is so much more than just these basic building blocks. The real magic is in the services that make applications smarter, stronger, and way more resilient. This is one of my absolute favorite concepts, auto-scaling. Just follow this story. An online store has a huge flash sale, and bam, website traffic explodes. But instead of crashing, AWS sees the surge and automatically adds more servers to handle the load. A few hours later, the sale ends, traffic goes back to normal, and those extra servers are shut down automatically. The result? A perfectly smooth experience for customers, and the store owner only paid for that extra firepower for the exact time they needed it. Brilliant. AWS also puts incredibly complex tech, like machine learning, right at a developer's fingertips. A service like Amazon SageMaker gives them all the tools they need to build and train AI models. These models can do things like predict what you'll buy next or spot patterns in data that a human would never see, essentially giving any app a layer of intelligence. Okay, so we've looked at all these abstract tools and services. How does this actually connect back to the real world? Let's go back to those companies from the beginning and see how they're putting all this stuff to work. You know how Netflix just knows what you want to watch next? That's not a lucky guess. They're using AWS data warehouses to churn through unimaginable amounts of viewer data, finding patterns that power that scarily accurate recommendation engine. For a game like Fortnite to even exist, it needs mind-boggling performance and scale. Epic Games uses a whole cocktail of AWS services, like EC2 for the raw compute power and DynamoDB for super fast data access, to make sure millions of players can all be in the same world at the same time without any frustrating lag. And here is a super powerful use case for that machine learning stuff we talked about. Capital One uses AWS to analyze millions of transactions as they happen. The AI models are trained to spot weird patterns and can flag potential fraud in an instant, adding a huge layer of security for all their customers. Airbnb's entire global marketplace, connecting millions of hosts with millions of travelers, all of that is built on top of AWS. They rely on those core services, the compute, the storage, the databases, to make sure their platform is reliable and can handle traffic from all over the world 24/7. So, to boil it all down, AWS gives anyone on-demand access to the kind of tech that used to be only for the biggest companies on the planet. It lets any app scale up to handle millions of users. And that pay-as-you-go model completely changed the economics for startups. It really truly is the invisible engine powering so much of our digital world. Now, there's no question this cloud infrastructure has unlocked a wave of incredible innovation. But it does leave us with a pretty fascinating question to think about. What does it mean, the good and the bad, when so much of the internet, so much of our digital lives, depends on one single company's platform?
Something to chew on. That's it for this explainer. Thanks for joining me. And as always, stay curious.